Well, welcome to the podcast. Welcome to Good News Format. This is the podcast that looks at the big questions of the universe and of our hearts. We're delighted to have Dr. Hugh Ross on with us. Hugh Ross is a Canadian astrophysicist and a Christian apologist, and he is an old Earth creationist. He obtained his Ph.D. in astronomy from the University of Toronto and his B.Sc. degree in physics from the University of British Columbia. And he is the founder of a website called Reasons to Believe that I'll link in the description below. He's also the author of a number of books, and I have only read two of them. But the first one, I'll really recommend it, Why the Universe is the Way It Is. That's about the fine tuning of the universe. And if you remember the podcast that we did with Luke Barnes, it's a good addition to that discussion. But the book that we're going to be thinking about tonight is Improbable Planet, how the Earth became humanity's home. And we're going to think about the special nature of, so my rule is that if the book stands up, it gets advertised. So there we go, it's standing up. So we're going to be thinking about the special nature of our planet. So welcome, Dr. Ross. Really appreciate you being on with us. And if you want to tell us a wee bit about yourself, about your career, home life, or hobbies, or something like that.
Yeah, well, I was born, raised, and educated in Canada, as you introduced. I was not raised in a Christian home, but I did get very interested in astronomy starting at age 7. In fact, as I was growing up, I was reading 4 or 5 books on physics and astronomy every week. I knew that my future career would be astrophysics, but it was when I was 16 that I studied cosmology and realized the universe must have a beginning. And if the universe has a beginning, there must be a cosmic beginner. So starting in age 17, I went on a quest to find the cosmic beginner, reading first the works of Immanuel Kant and René Descartes, and discovered they had the wrong concepts of space and time. So that's when I began to dig into the world's religions. And finally, I picked up a Gideon Bible given to me in a public school, began to go through it, and realized this is the one book that really, from ancient times, accurately described the state of our universe. And after studying it for about 18, 19 months, I realized this book accurately predicts future scientific discoveries. It must be inspired by the one that created the universe. And at age 19, I signed my name in the back of that Gideon Bible, committing my life to Jesus Christ, and then began to immediately look for opportunities to share evidences for the Christian faith with my fellow students and professors. Wound up at Caltech, and at Caltech, I found a Bible-believing church, and they put me on the pastoral staff. I've been on the pastoral staff of that church ever since, and that was that church that actually helped me launch Reasons to Believe. And I've been serving as a president of Reasons to Believe for the past 37 years.
Very good. I actually came to faith when I was 19 as well. So that's a good age for it now. What area of astrophysics did you study?
Predominantly quasars and galaxies, and typically the more distant quasars and galaxies in the universe. I was really interested in the very energetic galaxies and quasars and what the energy mechanism was driving them. We now know it's supermassive black holes that are sucking in huge quantities of matter in their vicinity that's responsible for that quasar/blazar phenomena.
Okay, very good. What do you do to switch off? What do you do for hobbies or time away?
Well, I grew up in British Columbia, so I really love the mountains. Okay. And so hiking and mountaineering, those are my hobbies. And every year I try to get to some really remote, beautiful mountain scenic location.
Very good. Well, you'd love Ireland. Have you ever been to Ireland before?
Yeah, I've been to Ireland. And I mean, it reminds me of British Columbia and how green it is. I mean, all that rain, I mean, makes things very green. So
and very wet.
I like the rain because of what it does to the beauty of the area. Yeah. So
very good. How long ago were you in Ireland?
I was in Ireland just before the pandemic, and Southern Ireland, I hear Northern Ireland and Western Ireland are especially beautiful. I didn't get to see those parts.
Okay. Well, that's where Armagh is. It's just near the big loch in the middle, or the big lake in the middle of the north.
Yeah, I know where it is. Yeah, you're in a nice spot.
Yeah, we like it now. We like it. Brilliant. Well, you define yourself as an old Earth creationist. What do you mean by that?
Well, I mean, when I picked up the Gideon Bible, began to go through it, I realized almost immediately these creation days in Genesis 1 must be 6 consecutive long periods of time. And so I take the view that these days are consecutive ages of time. And therefore, I never saw a conflict between what astronomers tell us is the age of the earth and the universe and what the Bible tells us is the time scale for creation. So that's a predominantly old earth definition. We believe that the days are long time periods rather than short time periods. Just recognizing, for example, when you look at Genesis chapter 1, it's obvious without knowing any Hebrew that this word day must have at least 3 distinct literal definitions, because 3 are used in the text. I mean, you got Genesis 2:4 telling us that the word day is used to describe the entirety of creation history.
Okay, so you see no conflict between the Bible and scientific understanding?
Well, I actually do see a conflict between the Bible and a young earth interpretation, because I tell people it's not enough to read the Bible literally on the creation text. You have to read it consistently. And what you notice when you go through Genesis 1 is that the first 6 days are closed out. You've got an evening and a morning. And, there are 3 different Hebrew definitions for both the words evening and morning. But at a minimum, without knowing any Hebrew, you realize it's telling us each day has a start time and an end time. But when you get to creation day 7, there's no beginning, there's no evening and morning phrase, which tells us we're still in God's 7th day. And that's exactly what you see in Psalm 95 and Hebrews 4, that we're still in God's 7th day when he's resting from his work of creation. Now, I told you earlier, I was a very serious student of astronomy growing up. And it was my parents who were worried I was being obsessive about astronomy. And so when I was 11, they bought our family this big, thick book on evolutionary biology. I was the only one that read it. But I remember telling my parents, the numbers don't add up. We have all these new orders and phyla and classes showing up before humanity and none afterwards. When I picked up the Bible for the first time, it gave me an answer for the fossil record enigma. For 6 days, God creates. On the 7th day, he ceases from his work of creation, which explains why we see all these phyla and classes in order before humanity, but we don't see any new ones coming after humanity. So that's solved for me a big scientific issue, just seeing what I saw in the first 2 pages of the Bible.
It seems to me the more we take the Bible seriously, the more it actually starts to make sense.
Absolutely.
Very good. Very good. That's helpful. Thank you. So you wrote a book called Improbable Planet. Why the title?
Well, I never get to choose the titles of my books. So,
Okay.
the marketers always do that. And I published that with Baker, and they get to choose a title. But the book is really about all the fine-tuned designs of planet Earth that we can see in the past history of the Earth that make it possible for a planet to have billions of people on the planet at one time with the technology, so that the good news of salvation through Christ may take into all the people groups of the world. So it's really a fine-tuning book, but I'm making the point that there's one level of fine-tuning you need to get bacteria and microbes, but a much greater degree of fine-tuning that you need to get plants and animals, and exponentially greater fine-tuning to get humans. But the most exponential growth of fine tuning that's needed is where you need to have design so that billions of humans can be redeemed from their sin and evil. That's where you get the most potent fine tuning argument. And Improbable Planet is the first of 3 books I brought out that's basically making that point.
Mm-hmm. So just sink into that a wee bit further, that idea of difference of life. I think in your book, you said that life differs by degree, not by kind. I think is your expression that you use. Could you unpack that a wee bit further, what you said of the different degrees of life there?
Sure. Well, I mean, what you see in Genesis 1 is 3 distinct origins of life, where you got God creating physical life, and that's on creation day 1. The Spirit of God is brooding over the surface of the waters, bringing life in the waters. And we know from science that the first life on planet Earth was microbial marine life. So that's creation day 1. And creation day 5 is when you see the second use of the word bara in Hebrew, the word that means create.
Mm-hmm.
Only 3 times is that word used. In Genesis 1:1, when God creates the physical universe, creation day 5, when God creates soulish animals. These are animals that are not just physical, they have the soulish characteristics of being capable of manifesting mind, will, and emotions.
Mm-hmm.
It's referring to these birds and mammals and how God gave them these attributes so that they could form relationships with a higher species and serve and please that higher species. And the last time you see that word create is when God creates human beings. And we're distinct from all other life in that we are physical, soulish, and spiritual. So we're endowed with a spirit that enables us to form relationships and serve and please a higher being. So as the birds and mammals are designed to serve us, we are designed to serve God. And, as we have been designed to come to God and relate to him, these animals have been designed to come and relate to us. But I love what the book of Job says. It says that just as our sin causes these animals to run away from us, instead of how they've been designed to come to us, likewise our human sin causes us to run away from God instead of coming towards him. And also what you see in Job is that when these animals are emotionally bonded to us, they outperform their wild cousins. Likewise, when we humans are bonded to God, we're able to perform at a far greater level than when we were not bonded to him. And as I've engaged Christian scholars around the world, I really see that. Their capacity to perform goes up exponentially once they have that relationship with Jesus Christ.
So whenever you hear reports on the news that people have found life on planet Mars or life on an asteroid, it is careful to define what life is.
Yes, that's true. And I've been on record since the 1980s that we will inevitably find the remains of life on almost every solar system body. But it'll be the remains of microbial life that's been transported from the Earth. Because Earth has been so prolific with life for so long, and we've been bombarded by meteorites throughout that time, that it's inevitable that the larger meteorites will export Earth's soil throughout the solar system. And so I've written articles making the point that of all the solar system bodies, the moon will have the greatest amount of these remains of Earth life. And it's not a trivial amount. We're looking at about 20,000 kilograms of Earth soil on every 100 square kilometers of the moon's surface.
Really?
And one ton of Earth soil has got 100 quadrillion microbes in it. So the moon's a great place to find the remains of Earth's first life. And you know what excites me about that? We'll never find those remains on the Earth. Earth's geology has destroyed the remains of Earth's first life. But the moon has almost no geological activity. If we go to the moon, we can find the pristine fossils of Earth's first life. And that will tell us who got the origin of life model right,
Huh.
the atheists or the theists.
Okay. Very good. That's interesting. I never thought of
And
that.
Mars works too,
Uh-huh.
but we're looking at only 200 kilograms for every 100 square kilometers of the Martian surface.
Mm-hmm.
It'll be easier to do it on the moon than on Mars.
Yeah, absolutely. Closer. Um, very good. So, improbable planet. Then, what factors go into making an Earth? Let's start there. And then we'll go on to why is it so improbable. So, what factors go into making a habitable planet?
Well, a remarkable thing about Earth is that it's big enough and dense enough to have plate tectonics activity and a strong magnetic field which establishes a magnetosphere that protects the Earth. But what we now see, and when we look at planets outside the solar system, planets the size and mass of the Earth at the appropriate distance from their host star where liquid water can exist on the surface, those planets have atmospheres that are thousands of times thicker than the Earth, and they have oceans that are hundreds of times deeper than we see here on the Earth. And so we have the problem that they got too much carbon and too much water. Now, what delivered Earth from that problem of having too much water and too much carbon is that Earth formed as a result of a collision event. There was a proto-Earth, so our solar system, we now know, began with 5 rocky planets. And one of those rocky planets, the planet Theia, merged with the Earth when the Earth was really young. And it was the merger of the proto-Earth with Theia that caused the proto-Earth to lose almost all of its water and almost all of its atmosphere. And that also led to the formation of the moon. And we now know without the moon, there'd be no life here on planet Earth. And so we realize it's this extraordinary birth moment. And the fact that we now have a relatively small rocky planet orbited by a gigantic moon. And that established a coupled magnetosphere in the early history of the Earth-Moon system that prevented our Earth from losing 100% of its water and 100% of its atmosphere. So that's a point I'm making Improbable Planet. The amount of water and the thickness of our atmosphere must be extraordinarily fine-tuned, and it takes highly fine-tuned circumstances in Earth's early history to make it happen. And I also tell a story of how astronomers were looking at this moon formation event and the merger of the 2 planets. And as they studied it, they said, the level of fine tuning is way too high. We have to redo the models to find a naturalistic explanation for this Earth-Moon system. So they redid all the models and they wound up with way more fine tuning than they had in the first place. And I love what the British journal Nature published. They published 6 articles on this moon forming event. And one of them, Tim Elliott, he commented, all this fine tuning is causing all of us modelers philosophical disquiet. But today we know the philosophical disquiet is even greater than it was when that got published in 2013.
It is very recognized, like among the academic community, the fine tuning of the universe. Would that be a fair statement?
That's a fair statement. What we're trying to promote at Reasons to Believe is we not only see fine tuning on the scale of the whole universe, we see it at all cosmic scales, all the way down to the interior structure of the moon and the Earth. So whether you look at our galaxy cluster, you look at what's called the local bubble or the local fluff that exists around our solar system, you look at the asteroid and comet belts, everything is fine-tuned. It's fine-tuned at all size scales, which really makes the point. The entire universe has been designed to make a home for us human beings.
Well, let's back up a wee bit and let's dive into this a little. So you've mentioned there the galaxy and superclusters. Go from the big to the Earth, and could you just walk us through
Sure.
why it like our even the shape of our galaxy and why that's important, why it's important the distance between galaxies? Could you go from the macro to the micro there for us and give us
Right.
a measure of the fine tuning?
I'll go through it quickly, but I've
Yep.
actually got an entire book coming out on that in June called Design to the Core. And I begin by making the point, uh, why do we need such a huge universe? There's 2 trillion galaxies in our universe. Why do we need all that stuff? Well, the answer is the mass of the universe determines what elements you get. And so the universe starts off as pure hydrogen in terms of the periodic table. And the mass of the universe determines how much of that primordial hydrogen gets fused into helium in the first few minutes after the cosmic creation event. And if you get too little helium, the future stars will not be able to make any elements heavier than helium.
Because they'd be too small. I mean,
well, the problem is you need a certain ratio of helium to hydrogen for stars to be able to take that ratio and make carbon, oxygen, nitrogen, iron, and all the rest of the elements.
mm-hmm.
If it's not enough helium, you get a block, and nothing can be fused in the nuclear furnaces of stars that's heavier than helium. Okay. So the universe would be forever nothing but hydrogen and helium, which would make it easy for everybody to pass a chemistry class, but there'd be no life. Yeah. There'd be no carbon, no oxygen, and no nitrogen. Mm-hmm. On the other hand, make the universe the tiniest bit more massive, you get so much helium being produced in the first few minutes that the future stars will take all that helium and quickly fuse all the hydrogen and helium into iron and elements heavier than iron. And in that scenario, you also get a universe with no carbon, no oxygen, no nitrogen, and no possibility for life. So the total mass of the universe must be exquisitely fine-tuned to get the elements you need for life. They also must be exquisitely fine-tuned to get stars and galaxies. Like a hobbit. Sorry about that.
Okay, don't worry. So, because that's interesting, because that's one of the arguments that I hear that atheists make, that the universe, because of its size, it's waste.
Right. Yeah, they make that comment all the time. Mm-hmm. And the truth is, the universe must be exquisitely fine-tuned in terms of its mass and its size, mm-hmm. how far apart the galaxies and stars are, if you want to get life in the universe. Mm-hmm. And the degree of fine-tuning is extraordinary. If it wasn't for dark energy, you'd have to fine-tune the total mass of the universe to 1 part in a quadrillion, 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 quadrillion. And you say, well, does it go down with dark energy? Yes, it does. But now you got to fine-tune dark energy to a far greater degree than that 1 part in 10 to the 60th. And that's the level of the whole universe. Mm-hmm. And, the library behind me, I got about 50 books on the fine-tuning of the universe. Mm-hmm. 48 of them are written by non-Christian astronomers. So he said at the beginning, this is not controversial. Everyone, regardless of the theological perspective, concedes that. But what I notice in the books written by the people who are not believers is they stop at the level of the universe. That allows them to put the cosmic creator so far away that they don't really have to concern themselves about what that being thinks about how we're living our lives. So that's why I wrote Improbable Planet and Design to the Core, to say it's not just at a cosmic scale. I mean, if you just go a little bit closer, you look at what we call the cosmic web, how the super galaxy clusters and galaxy clusters seem to be oriented on a huge scale like soap bubbles, where you got the ordinary matter on the surface of the bubble, the exotic matter in the interior. I won't go into the technical details, but that has to be exquisitely fine-tuned for life to be possible. Mm-hmm. Then you begin to look at the super galaxy clusters. And there are tens of thousands of them in the universe. These are clusters of galaxies. But the one we live in, the Laniakea supercluster of galaxies, looks radically different than any other supercluster of galaxies we observe. Okay. The other superclusters of galaxies are giant balls or football-shaped structures where you got the galaxy.
Are you saying like American football or British football?
Oh, rugby. I mean, think you
rugby.
played rugby when I was in Canada. You may probably played it.
Yeah,
so
okay.
A rugby ball, okay, and a ellipsoid.
Yeah. Okay, so that's the shape of our cluster.
Our cluster doesn't look like a basketball or a rugby ball. It looks like kind of a praying mantis, like a stick insect. Okay. So instead of all the galaxy clusters being jammed tightly together, they're spread out along these long, thin filaments. But that's exactly what you need for light to be possible. That's what prevents us from being too exposed to these supermassive black holes where the radiation would knock us out, where you got the galaxy clusters jammed too tightly together, you got them strung out. And then we realize we also live in a galaxy cluster like no other. We live in what's called a galaxy group. And we've scoured the universe to try to find a galaxy group like our local group. Galaxy groups typically have a few giant galaxies and then a bunch of other galaxies. Ours has no giant galaxies. It's got 2 large spiral galaxies and over 100 tiny dwarf galaxies. We don't see any other local group like that, but that's exactly the local group you need to get a large spiral galaxy that's going to remain undisturbed for billions of years, where it can maintain its spiral structure through absorbing tiny dwarf galaxies on a regular basis. And I don't know whether you're a Star Wars fan. Yesterday was May the 4th. That's kind of a day where they say, May the 4th be with you. And I like the humor in the Star Wars galaxy or Star Wars movies. The science is awful, but the humor is great. But the problem is each one of those movies begins with a comment, a galaxy far, far away. Yeah. Astronomers have looked at galaxies far, far away. We're not finding any candidates for advanced life. And one thing I put in my new book, Design to the Core, I show you panels of the 12 spiral galaxies that we have found that come the closest to matching our Milky Way galaxy. But none of the 12 come anywhere close to having the spiral structure you need to make advanced life possible. So even though there's 2 trillion galaxies in the universe, it really does appear we're living in the one galaxy where advanced life is possible. And our solar system is in the one location in our Milky Way galaxy where advanced life is possible. And my point is the fine tuning is at all different size scales. You go inside of our, we're inside what's called the local bubble. We're looking in a local bubble that's fine tuned for advanced life. Then inside the local bubble, we got the local fluff. That local fluff is also fine tuned. Our star is fine tuned. We've been scouring for 60 years to find a star sufficiently like our sun to be a candidate to have a planet about it with advanced life. We found lots of stars that are twins of one another, but no twin of the sun. And so, I mean, I got friends who are involved in the search for extraterrestrial intelligent life. And I tell them, why are you observing all these planets that you think are candidates? They're all orbiting stars that we know are non-candidates. Until you find a star like the sun, don't bother wasting the telescope time.
Well, let's take that apart a little, if that's okay. Because you dealt with the clusters. Why a spiral galaxy? Why is that conducive to life where an elliptical one wouldn't be?
Well, the problem with spherical and elliptical galaxies, and those make up 90% of all the galaxies we see, is that they were spiral and the spiral structure is collapsed. And so what you have is this galaxy collapsing, and now the stars are really jammed tightly together.
Okay.
And when you've got stars jammed tightly together, that means the planets are going to be exposed to radiation. They're also going to be exposed to gravitational disturbances. Because, if you got a nearby star, that's going to disturb the orbits of the planets over a period of time.
Mm-hmm.
That's a requirement for advanced life. You have to have a planet with a highly fine-tuned orbit that remains undisturbed for billions of years.
Okay, and a spiral galaxy offers that stability.
It offers that stability in one location. So, for example, you have to be really near what's called the co-rotation distance. So you look at our galaxy, there's a particular distance from the center of the galaxy where a star will revolve around the center of the galaxy at the same rate that the rigid spiral structure rotates. And if you're right at the co-rotation distance, you'll suffer mean motion resonances, which will kick you out of that location. The best spot is just inside. And just inside means you're only going to be crossing spiral arms about once every billion years.
Okay.
Every time you cross a spiral arm, you're going to be exposed to giant molecular clouds and supergiant stars.
Okay.
And we crossed a spiral arm 500 million years ago. And so right now we're in between the Perseus and Sagittarius spiral arms. That's the one place where you can have advanced life.
That's incredible, like that incredible kind of fine tuning from the clusters to our galaxy. And you're saying that it's further fine tuned to our sun. So what is so unique about our sun then that's conducive to life?
Well, what's special about it is that it has an extremely stable luminosity. So there's been a search by my fellow astronomers to find stars with a luminosity stability that comes the closest to matching the sun.
Sorry, by luminosity, you mean output of light?
Brightness.
Right, yeah. Mm-hmm.
The light that it's emitting.
Mm-hmm.
And all stars, their brightness varies, but our star, the sun, has extremely low light intensity variability. And the closest we've found to matching the sun is a star where the brightness instability is 5 times greater than our star, the sun.
Okay.
And that wouldn't rule out microbes, but it does rule out advanced life and advanced civilization. The other feature of the sun is it has extremely low flaring activity.
Mm-hmm.
And again, that's not a problem for microbes, but it certainly is a problem for advanced civilization. Mm-hmm. Matter of fact, there was a flare in 1859 that knocked out the world's telegraph systems. Right. And we've been fortunate. We haven't had a flare like that since. Mm-hmm. And in fact, one thing I'm putting in my new book is we need to be protecting the power grids of the world. There's only one power grid that's protected. That's the Quebec power grid in Canada, because it got knocked out in 1989 by a solar flare. And, Quebec is close to the North Galactic Pole, so it got the hardest hit. And then now they protected it, but the rest of the world's power grids are not protected. So if we were to get another big flare like we had in 1859, that could cause a lot of damage.
That's interesting. So from the cluster of the galaxy to the star, let's then get to Earth. And well, actually, before we get to Earth, let's go to the moon, because you raised that earlier. What is so unique about our Earth's moon?
Well, the moon actually serves multiple roles in ensuring advanced life is possible on Earth. Because you got a relatively small planet orbited by a really big moon. I mean, if you compare the mass of our moon to the mass of Earth, it's more than 50 times greater than any other planet moon system that we know of. But it's that high ratio of the moon's mass to the Earth's mass that stabilizes the tilt of Earth's rotation axis. So our rotation axis is now at about 23.5 degrees. Mm-hmm. It moves back and forth by about 1 degree. That's so tiny, it doesn't disturb the possibility of advanced civilization. But for example, if you go to Mars, which lacks that big moon, its rotation axis tilt varies back and forth by 60 degrees.
Hmm.
And that's typical of planets. Earth is the exception, and it's the exception because of the moon. And also, we notice that because the moon formed as a result of two planets merging, Theia and the proto-Earth, it started off very close to the Earth. And since that time, it's been spiraling away. And as it spirals away, it slows down the Earth's rotation rate. So when the Earth moon system was first formed, Earth had a rotation rate of about 2 to 2.5 hours per day. Now it's 24 hours per day. 24 hours per day is optimal for humans and human civilization. 25 would be a big problem. 23 would be a big problem. 24 is optimal. But you need to have the moon spiraling away from the Earth so that we hit that 24-hour rotation rate at that tiny time window when the sun's luminosity is optimally stable. We're talking about how stable it was. That stability period in the history of the sun only measures about 100,000 years wide. And so it's necessary that you sync up the slowing down of Earth's rotation rate with the aging of the sun. And so we're here at the optimal time.
That's amazing. That's so precise. Like even having the moon that size, that's incredibly precise. So then let's drive down into Earth itself. What are the properties that you need to have a habitable planet? You talked about the core earlier on and the magnetosphere.
Yes, well, if you look at the history of the sun, I mean, right now it's extremely stable, has very little flaring activity. But in the first, say 400 or 500 million years of the sun's existence, that level of flaring activity and luminosity stability was about 100,000 times greater than it is today. And there was particle radiation coming up from the sun. And what preserved the Earth's ocean and the Earth's early atmosphere was the fact that the moon was close to the Earth. And because the moon and the Earth formed as a result of these two planets colliding with one another, that meant that the early Earth had a very hot interior. And likewise, the early moon had a hot interior. That also means that because they had this hot formation event, the iron and the nickel settled into the core of both the early Earth and the early moon. And if you got circulating liquid iron in the cores of both of those bodies, that will establish a strong magnetic field. And so we have the liquid core, but now you need to circulate it. But because the Earth and the moon were close together early, the mutual tidal forces they exerted in one another circulated the liquid iron in the core of both bodies. So both bodies had a strong magnetic field, and both bodies were so close together that the magnetic field coupled. And so it's the coupling of that early magnetic field that prevented the early sun from sputtering away all of Earth's atmosphere and all of Earth's water. And now the moon has moved away where those tidal forces are no longer strong enough to circulate the liquid iron in the interior of the Earth. But what happened was the core of the Earth began to cool. And it cooled sufficiently that instead of the core being completely liquid, the interior is solid and the exterior is liquid. And that allows a flow of light elements trapped in the interior of the solid core to move up into the liquid core, and that circulates the liquid core. So now we got a different circulation mechanism. But the bottom line is everything's fine-tuned to ensure that there's a strong enough magnetosphere around the Earth to protect life on Earth from deadly solar radiation and deadly cosmic radiation.
That's incredible. That's incredibly fine-tuned.
Yeah, and that was just discovered a year ago.
Oh, really?
So, yeah. I mean, that's kind of the point we're making in our books at Reasons to Believe. The more we learn about nature, the greater evidence we get for the supernatural handiwork of the Creator. And so literally every week that goes by, new stuff gets published in the scientific literature. I mean, if you go to reasons.org, I got a blog called Today's New Reason to Believe, where I keep up to date on the latest of these new discoveries.
Very good.
And if I had the time, I could write 10 articles a day, because that's how much this stuff is getting published.
Very good. Very good. So those 48 books on your shelf about the fine tuning, a lot of them not a Christian or theist, they would then say that this was just one big accident, that it was a fluke. Are they?
They're not saying that. They're saying there definitely is a causal agent beyond space and time that designed the universe so life would be possible. But mainly they're taking the theological position of deism, that there's this causal agent that created everything, but the causal agent isn't involved beyond creating the universe some 14 billion years ago. And so what I'm trying to do in my books is to show it's not just deism, it's theism.
Yeah.
We're actually looking at a personal creator because he's fine-tuning not just the beginning of the universe, but all throughout the entire history of the universe. And all of the focus seems to be on making a suitable home for human beings, which makes the point. We're not just dealing with a personal being, we're dealing with a personal being that has a very high value for humans and really cares for us humans and has a purpose for us humans. And then I raise the question, what is that purpose? Well, the fact that the fine tuning is most spectacular in the context of redeeming humans from their sin tells us this is the God of the Bible.
I remember years ago, a Bible teacher, a man called David Gooding, and he monitored upon Genesis 1, and he said, just notice that it wasn't created in one go, but it was God intervening, God intervening, God intervening, God intervening, and kind of fine tuning, that it's the hands of God almost, you know. For an atheist, though, an atheist would say that it's a fluke. I would say it's just chance, like quote Brian Cox, I'm just lucky to be here. What would you say to that? Why would you say it's not a fluke?
Well, I remember back in the 1980s making the prediction, eventually the evidence for fine-tuned designs to make a home for us human beings will become so utterly pervasive and overwhelming that atheists will have nowhere else to go but to say it's just pure chance. But to make the pure chance work, they're going to have to hypothesize that there's an infinite number of universes, all that are different from one another, and therefore by pure chance, we're living in the one lucky universe where everything is just right. And today they call that the multiverse, where they're speculating about these infinite number of universes. But I remember saying in the 1980s, whenever an atheist has to appeal to infinity, they're basically conceding we have no evidence for our position. And I love what Leonard Susskind said. He's a famous American atheist theoretical physicist. And he said, we atheists have got to stop using the multiverse. It's a bad argument. It explains everything. And an argument that explains everything explains nothing. Well, he kind of stopped right there. What I did in the 4th edition of The Creator and the Cosmos is to give lay people an analogy for his point. And that is, if you've got an infinite number of universes where they're all different from one another, you're going to get an infinite number of planets, just like planet Earth. And on planets like Earth, you get birch trees. And birch trees have a property that they peel white pieces of bark. Well, if you've got an infinite number of universes, you're going to wind up with an infinite number of planets like Earth with an infinite variety of birch trees. And you're going to find a place, a planet, that has birch trees that peel thin rectangular pieces of bark that measure to be the same size of the papers that we put into books and to journal articles. And those random pieces of white birch bark are going to fall on soils with random chemicals in them that'll make markings on those pieces of rectangular, thin white birch bark peelings, which will duplicate all the paragraphs, diagrams, equations, figures that you see in every scientific research paper that's ever been published, which means all those scientific research papers, they did not come from the minds of scientists. The multiverse did it. And so my point is, if you're going to appeal to the multiverse to get rid of God's fine-tuning, it simultaneously gets rid of all human fine-tuning. And so you're basically making the point, it's a philosophically inconsistent argument.
No, that's helpful. That's helpful. So then for you personally, I know you told us a wee bit about your journey towards God, but if I was to ask you, why does the fine-tuning point you towards God, what would you say?
Well, it not only points me towards God, it points me towards a personal God who has the purpose of redeeming billions of human beings from their sin and evil and training them for future careers in a brand new creation. And I think that's a powerful point. The fact that God designed the universe with specific laws of physics. I mean, you were referring earlier to why the universe is the way it is. I basically make those laws of physics have been fine-tuned along with the universe to make a home for us, but it's designed to prepare us for a future career. So to me, what makes the fine-tuning argument potent is the fact that everything's been fine-tuned to be the equivalent of going to a university and taking a bunch of courses and being prepared for a really fulfilling career. And that's, to me, what is special about the Christian faith compared to other world religions, is that what we see in the Bible is a two creation model. God creates the universe to be a tool in God's hands to eradicate evil and suffering. But once evil and suffering been eradicated, God replaces the universe with a brand new creation. And right now, he is training and preparing humans here on planet Earth who desire to be with God for the rest of eternity for future careers in the new creation. And I appreciate what the Apostle Paul says, run the race of your terrestrial life for all you're worth, because if you run it for all you're worth, it will prepare you for an incredibly rewarding career in the new creation. So these 80 or 90 years we have here on planet Earth, we need to really value them carefully and live those 80 or 90 years in such a way that we can be prepared for an eternity of an incredibly rewarding career in the new creation.
No, that's helpful. That sounds exciting. It sounds more exciting than even what the next world is propaganda to be, that you're sitting on a cloud twanging a harp, but it's actually a new creation,
It's a brand new creation. We do not know what God's going to create in the new creation, but he's already told us the angels will be there. And because we've experienced the grace of God, whereas the angels simply observe the grace of God, it says we'll be teaching, instructing, and ruling over the angels. And so right now we're lower than the angels, but a time will come when we'll be elevated above the angels. The reason why, we're going through the training, the angels are not. They're watching us go through the training, but we have the privilege of directly experiencing the grace of God. And it's through that experience of the grace of God that we get prepared for these future careers.
Well, that's helpful. That is helpful. Well, listen, is there anything else that you want to add to that? I know you could add, I get the sense that you could add a few more hours worth of podcast, but is there anything else?
Definitely could. But I think a good way to wrap this whole thing up is just to make the point again, hey, if you're a skeptic about any of this, wait 1 week, wait 1 month. I mean, literally every day we're learning more about the book of nature. And that's what I love about what the Bible says. God says, I gave 2 books. I've given you the book of scripture and the book of nature. They're both trustworthy revelations from me. And so he says, everyone is without excuse because everyone's been exposed to nature. But our mission at Reasons to Believe is to expose people to the book of nature and show them how the more we learn about nature, the more evidence we get for the supernatural handiwork of God, and use that as a tool to bring them to the book of Scripture and into a relationship with Jesus Christ. So yes, Reasons to Believe is an apologetics organization, but it's an apologetics organization where we focus on those evidences that are going to help people realize there's a God out there and a God that desires to redeem them from sin and evil and to prepare for a future career in the new creation. What could be more exciting? So don't ignore the two books. God gave us two books. We need to read both.
Well, thank you so much indeed, Dr. Ross, for coming on. I'll put a link to his website in the description below. I'll also put a link to those books that you can buy for yourself online. And again, thank you so much for listening. If you do have any questions, any comments, any areas that you do want us to think about and talk about, please do get in contact. There are a couple more of these interview Ask the Expert podcasts on the way. So do follow the Facebook and do tune in. And again, thank you so much for listening.